afternoon. Um, I hope you are doing great. Now, on the board is a question on equilibrium of forces. What is equilibrium? Equilibrium or a body is said to be in equilibrium when it is either stationary or moving at constant speed or at uniform angular velocity. The acceleration, there's no change in direction, right? Now, to solve this kind of problem, so what is the value of T1 and T2 in the figure below? To solve this kind of problem, we are going to convert this diagram, which is otherwise known as free body diagram. We are going to convert it to triangle of forces, and it's quite simple. All right, now follow me so that you can understand how it is being done. Solution. Now, this T1 and T2, they are known as tension. Tension is a force in a string or rope, right? So, or in a cord. So, assuming these two are ropes or a string. So this is T1, this is T2. Why this force here is the weight of a body, all right, or the weight of the body. Now, because it's acting downward. Are you with me? So, to to change this free body diagram into equilibrium of forces, I would advise you start with the weight of the body. So the weight of the body is acting downward. So I'm going to draw something like this. This is 100 Newton. All right. Now, if I extend this, you notice that this is T 100 Newton. So, and this is T2. So I'll just take it from here. This is T2, T2, and then this is my T1. You can see the arrow. The arrow must enter themselves. You can see the flow. All right. You can need the vector diagram as it were. So this is my T1. Now we are done with the side. Now let's now shift focus to the angle. How do we enter this angle into the triangle? Now I want you to understand that from here to here is angle 30 degrees. All right, but I need to find the angle from T1 to this place. This is 90 degrees. So 120, 30 plus 90, everything is 120 degrees. The same thing here. Everything here, this is 90. 45 plus 90 is 135 degrees. All right. So this need to be set to first. Now, the angle between T1 and 100 Newton is 120 Newton. So you locate T1 100 on this triangle or in this triangle. So this is T1 and this is 100. So this 120 will be outside, is the exterior angle, and this is angle on a straight line. So when you bring it in, it becomes 60 degrees because angle on a straight line is 180 degrees. 120 plus 60 is 180 degrees. So that is for this. Now for T2, the angle between T2 and 100 Newton, this is T2, line T2, and this is 100 Newton. So you can see 135 degrees. So the angle inside will be 45 degrees because 135 plus 45 is 180 degrees, which makes up angle on a straight line. So from triangle, the sum of angle in a triangle is 180 degrees. So 60 plus 45 is 105. 105 plus what gives 180? Obviously, it is 75 degrees. So we are done with the completion of the triangle. Now the next thing we're going to do is to find the values of T1 and T2. Now you will notice that this is scaling triangle. This is scaling triangle because the angles are different. So in order to find T1 and T2, we shall be using a sine rule. There's a rule in trigonometry called sine and cosine rule. We'll be using sine rule. So to find T1, I'm going to connect this angle with T1 because T1 is opposite this angle, and I will connect it, I will link it with 75 degrees and 100 Newton. So using sine rule, I have that T1 over sine 45 degrees is equal to 100 over sine 75 degrees. When you cross multiply, T1 becomes 100 sine 45 degrees over sine 75 degrees. Alright, so let me get my calculator to resolve it. So 100 sine 45 divided by sine 75. So this is T1 is 73.21 Newton. So this is the value of T1. Alright, so to find T2, you will follow the same procedure. Alright, it will be T2 over sine 60 degrees equals to 100 Newton upon sine 75 degrees. And when you follow the same process, the same step procedure, you will get the answer for T2. All right, so you can try that yourself. It's a very simple question. All right, there's another way this question can be solved, but it's very long. That is when you resolve each angle along the horizontal component and the vertical component, as if you are doing resolution of forces, but it's quite long. But this is better and it is shorter by